All right, learning target 1.4 practice. So making sure we know how to graph a system of inequalities, okay? So when we're graphing inequalities, okay, we start and just graph one inequality. So it's in slope-intercept form. So if I have a calculator, I'm just going to type in both these in my calculator and see what the graphs look like, see where they're shaded, see where they overlap. Okay, in this case, I'm doing it by hand because I don't have my calculator with me. So, slope-intercept form, start at positive 1, slope of 1 over 2, up 1 to the right 2, okay, or down 1 to the left 2. Now remember, when we're looking at these, okay, we've got to decide if this line here is solid or dotted. There's an equal to underneath, it's solid. Then I look and say, okay, y is less than. Well, to make y less than, I'm going to have to go down, aren't I? Okay, so I shade that one, graphed that one. Now I'm going to do the second one. So y-intercept of negative 1, slope of 3 over 2, so up 3 to the right 2, or down 3 to the left 2. Okay, there's no equal to here, so I'm going to draw a dotted line, which means the line isn't part of the solution. Okay, y is also less than, so I'm going to shade below here. And then I look, my answer is going to be the area where they're both shaded. So I'll shade this in a little darker, this zone right there. And that's what I'm looking for, that zone where they're both shaded. Okay, so that's all we do. Okay, so y is less than or equal to 1/2 x minus 1. So start at negative 1, up 1 to the right 2, or down 1 to the left 2. There's an equal to, so it's a solid line, y is less than, shading below. Okay, my second one, x is greater than negative 2, so negative 2. Now there's just an x, so it's going to be a dotted line because there's no equal to, vertical line at x equals negative 2, and then I shade to the right. And again, where do they overlap? That's the area that my solutions to both of these are going to be. Okay, so if I'm thinking about this, okay, I have 3 zones, right? I have this zone here that's not a solution to either of these. I have just the blue zone that's a solution to my blue inequality, just the orange zone, solution to just my orange inequality, and the gray is the only place where it's a solution to both. Okay, same with here. Solution to the green one, solution to the red one, solution to both of them, solution to none of them. Okay, but really when we're talking about a system, it's the gray area that we really care about, right? If I were to then go back and erase those parts, it's just that gray area that I want to deal with. Okay, so next one. So start at negative 2, slope of negative 3, down 3 to the right 1, or up 3 to the left 1. It's not equal to, so dotted line. Y is greater, shade above. Okay. Then positive 3, slope of 2 over x, so up 2 to the right 1, or down 2 to the left 1. It's a solid line, so because it's got the equal to, y is greater than, so again, shading above. And where do they overlap? That little slice right there. There's my answer. Okay, negative 2, up 5, to the right 1. It's a dotted line. Y is greater than, so shade above on the y's. Okay, x plus 2, positive 2. X is just 1 up 1 to the right 1. Again, dotted line, so draw my dotted line. Y is greater, so I shade above. So this one, where do they overlap? Right here, in that section right there. Okay. just continuing to go. -2, slope of -5, so down 5, to the right 2, so like down here, or up 5, to the left 2. There's no equal to, so dotted line. Y is greater than, so shade above. That one's done. Then +2, slope of down 1 to the right 2, because it's a -1. It's a solid line, so draw my solid line, which means that green line is part of the answer, but the red dotted line isn't. Y is less than, so shade below. Where do they intersect? Right in that area. It's all about where they intersect the shading. Okay, number 6, 3x minus 3, so -3 right here, up 3, to the right 1. Okay, it's equal to, so solid line. Y is less than, so shade below on the y-axis. Then we have a y is greater than 3. Okay, well, y at 3 is right here, right? So it's going to be a horizontal line because it's equal to, and then y is bigger, so we shade above, so they overlap right here. Okay. All right. Now what if we have standard form equations, okay? Now for these ones, again, the easiest way to graph these is to think in terms of if I have one and not the other. So if I got rid of the y, I'd have 3x is less than -4. Divide by 3, I'd have x is less than -4/3, which is like -1 1/3, so -1.3, so like right there. And it says x is less than, so to be less than for the x-axis, you shade to the left. Okay. Now, if I got rid of the x and not the y, I'd have 2y is less than -4. Divide by 2. Y would be less than -2. So go down to -2. Y is less than, so I'd shade that way. Now, it's a dotted line, so I've got my 2 points, and that's not a very good line. Okay. And I'm shading below. Okay. So it's just like that. So it's a little bit longer to graph it, right? But still the same idea. So if I had no x, 2y is less than 6, divide by 2, y is less than 3, so +3, but y is less than, so shading below. Then if I got rid of the y and had the 3x is less than 6, divide by 3, x is less than 2. 2 right here, less than. Okay, it's also equal to, not equal to, so another dotted line. Okay, shading below because x and y are both less than. So, basically, it's with the orange line, isn't it? Shading below that one, because they kind of overlap right there. Well, not kind of, they do. Okay, so the next one, that's all you got to do. Okay, so if there was no x or no y, we'd have 4x is less than or equal to -2. Divide by 4, x is less than or equal to -2 over 4 is really -1/2. So -1/2, oh, x, not y. And x is less than, so I'm going to shade that way. Then if we got rid of the x, it'd be y is less than or equal to -2. So -2, y is less than. It's a solid line, so we shade below. Okay, then our second one, if y were gone, it would be x is greater than or equal to -3. If x were gone, it would be -y is greater than or equal to -3. So, first of all, for the -3, x is greater, so we shade that direction. -y, we can't have a -y, so divide by -1. And then whenever we divide by a negative, flip the inequality, so +3 for y, and y is less than or equal to. So solid line, shade below. Where do they overlap? Right in that zone. Okay, so this is kind of the easiest way I can think of to show you guys how we do those ones. Okay, so number 9. Get rid of the y, it'd be x is less than -6. Get rid of the, so we're doing this one. The x would be 3y is less than negative 6 divided by 3. Y is less than negative 2. So negative 2 for y is less than. For x, negative 6, and x is less than. It's not equal to, so a dotted line, right? And they both shade below. And again, hopefully you're using a graphing calculator, and that makes this a lot easier, okay? So then this one, we'd get 4x is greater than or equal to negative 9. So we divide by 4. X is greater than or equal to negative 9 over 4, which would be negative 2.5, right? 2.5. So negative 2.5, and x is greater. Then if we got rid of the x, it would be 3y. Or is that a negative 3y? Yep. Negative 3y is greater than or equal to negative 9, divided by negative 3. We get y is less than or equal to positive 3. So positive 3 less than or equal to. It's a solid line. Shade right there. Where do they overlap? Right in that zone. Okay, number 10. 3x is greater than or equal to 2. Divide by 3. Doing this one. Get x is greater than or equal to 2/3, which is like 0.6. Like right there, x is bigger. If we got rid of the x, it'd be 2y is greater than or equal to 2. So y is greater than or equal to 1. So positive 1. It's equal to, so sketch my line. Shade in this direction. Okay, the second one. So it'd be 3x with a negative 2. So it'd look like that. So it'd be basically negative 2/3. And it would just be greater than, no equal to. So negative 2/3. X is bigger, so shading that way. Then the 2 would have a negative here, so it'd be negative 1. And y is greater. So this one's a dotted line. So these lines are actually parallel. And it's shading right there. So they overlap on that spot. Okay. All right, last two. Y is less than or equal to negative 1. So negative 1. And y is less than or equal to, so solid line, less than, shade below. Okay, x is less than, x minus y is less than 2. So x is less than 2. Negative y is less than 2, which divide by negative 1. We get y is greater than negative 2. So negative 2, y is bigger. Positive 2, x is smaller. Not equal to, dotted line. We can see which direction to shade. And we can also see exactly where we need to overlap and where we would be dealing with the overlapping. All right, last one. So we've got 4x is greater than negative 3. We'd also have 3y is greater than negative 3. So divide by 3. We'd have y is greater than negative 1. Divide by 4, we'd have x is greater than negative 3/4. Negative 3/4 is like negative 0.75 right there. X is bigger. For y, negative 1 right here. Y is bigger. There's no equal to, so a dotted line here. And we shade on that side. Then the last one, 4x is less than 6. Divide by 4. X would be less than 6 over 4, which becomes 3/2, which is 1.5. So 1.5, x is less than. Okay? Then we'd go 3y is less than 6. Divide by 3. And we get y is less than 2. So positive 2. Shade it that way. Again, a dotted line. We should be able to see exactly where they overlap. Which remember is the whole point of a system of inequalities. The solutions that matter are the ones that work for both inequalities which are in the overlapping area. Okay? And that's really all there is to it, guys. So there we go. Learning target 1.4.